Um, all right. So I guess we'll get going. Hey everyone, welcome. Got a few people watching, which is nice. Yeah, this is Ken. Ken is an assistant professor at Aarhus University in Denmark. He does a lot of work around gaze and hand tracking and combining gaze with different forms of input for multimodality. And yeah, we're going to talk a little bit about how to design for gaze and hand tracking. So throughout the talk, I'll be watching the chat. If there's any kind of confusion or any questions, yeah, leave them in the chat, and then I can poke Ken with them. And then at the end, we'll have a longer set time to do some Q&A. But for the moment, I'll hand over to Ken.
Right. Yeah. Thanks for the intro. So yeah, my name is Ken Pfeuffer. I am, as he said, I'm a professor now, and I thought I'll show a few videos first, because there will be a lot of a bit more theoretical slides coming up. But I worked with eye tracking and hand tracking a lot. So beginning on what you can see on the left, looking at eye tracking integrated into a tablet, for example, and the input was then combining touch gestures with where I'm looking, and that kind of led to some work. What you can see in the middle with gaze and pinch. Where you use your hand gestures with the eye tracking in virtual reality, and that's kind of what things you can see now with the Apple Vision Pro. And yeah, we also went further that and tried out different types of interfaces. And yeah, so I hope I can tell you a bit more about how to design for this. But first of all, my background, I started in Germany, did my PhD in UK. I think key things were also my internships in the States, where I was working with human-computer interaction researchers. And then went back to Germany, and now I'm in Denmark as an assistant professor. Yeah, so I have to warn you, so that's why I put this picture on. So from 2017, I guess I focused a lot on this particular combination of using, our eyes and the hands. And in this talk, you will go down the rabbit hole of this, because I went through that. And okay, I'm only going to show you the highlights, but that's kind of a little preview for the rest of the talk. And yeah, it might be a bit too much. So this is an overview of different papers and concepts I was proposing with different authors and different teams that I was working in across the different stages in my career. But I was really focusing heavily on this part. So I thought, how can I make a good overview of all of this stuff? And it's impossible. But just from a developer perspective, you can think of what you see on the left. There's this UI system, so the input from the user, and you get some output. And similar to like an operating system, that you have different input devices like a touchscreen, you can have a stylus, eye tracking, hand tracking, controllers. And each input device can be used for different techniques, so different ways to interpret the sensed input of the user. And if there are different ways, then you can also switch between them. And in the end, the last level is the application level, where you have these concepts, but then actually concretely, for whether it's for a drawing tool or for navigation or for menus, there can be different kind of implementation. So my research kind of covered all of these aspects, and one of them, the orange highlighted one, is the gaze and pinch one, which I guess is the most interesting now with the Apple Vision Pro happening. But yeah, I will also show a lot of other examples. That's kind of what I'm So especially on the touchscreen, what you've seen just now, that because that's kind of how it all started with me, and then I kind of extended it to the 3D space. Yeah, so this is the outline, a bit of motivation. Then I talk about my bigger vision, the eye-hand symbiosis. And then more concretely, gaze and pinch design. And the last part is on something more underexplored and not heavily researched, but how to bring together direct and indirect interactions, which is also kind of a follow-up from gaze and pinch. Yeah, so yeah, I'm a researcher, so I've been very heavily concerned with human-computer interaction. And one of the biggest quests is to find the new interaction techniques for a new context, for a new device platform, and so on. And if you look back into the past, there's been the mouse, the pen, and so on. And input devices are becoming more natural, more spatial. And we are here right now in XR having natural gesture interfaces and eye tracking, and things are becoming multimodal, meaning you as a user, you have the choice between a lot of different ways of interacting, right? Because you're in 3D, you have you potentially your voice, you can do different types of gestures, you can have an input device like a controller or a stylus. You can have a lot, the different rays or for distant interaction like head pointing, eye pointing, and even with a hand ray, different types of pointing. So it's like all of these possibilities are now there in 3D. Well, before that, on 2D screens, it was a lot more constrained, and we had this mapping of like typically one interaction paradigm per device. But of course, 3D means it's not a specific device. There's a lot of new things coming up from AR, VR, or IoT control. And there's a lot of application use cases, in my opinion. And eye tracking is now with the Apple Vision Pro, it seems like, oh, okay, shit, this is a huge innovation in that you cannot see it in any other consumer device really. So it is amazing, but if when you think of, okay, where has it been actually in the scientific world? It's actually has a quite long nose of innovation, if you want to say so. So in the 80s already, Bolt has proposed similar concepts. So my students typically know this example. I'm just going to quickly go over it. So I'm assuming that most people know it as well. But what Bolt did here is that he had this projection, different objects, and he used a kind of more natural interface of using voice and gesture.
Put that there. Move that below that. Move that west of the diamond. Create a large green circle there. Oh, shit.
Yeah, this can happen. So I guess the sensor wasn't perfectly calibrated, but yeah, you can see that the pointing in midair and integrating that in a multimodal way with voice has been proposed for a long time already. And we see, of course, voice interfaces nowadays with the phones and gesture interfaces coming up. But it's still, the eye tracking part is still quite a novelty. So when did that actually happen? And it's actually just 1 year later, the same person, Bolt, he had kind of the same setup, but this time he was operating the system with the eyes, and that was already in 1981. Unfortunately, here there's no text, but what you can see is he's wearing these glasses with something like an eye tracking sensor on the side that can measure the eye movements. And yeah, that's all you see in this video. But the functionality is that you have a lot of different screens, and each of them has their individual audio, of course. And whatever your screen you're looking at, the sound will be active. That was the main concept of it. And in addition to that, at the armrests, there were like joysticks. So you could provide some additional input. For example, you look at a screen and then it would zoom the content in, it would activate the audio, but you can still use the controller or the joystick to give more concrete commands like, oh, don't do that, or zoom in faster. So it was like one of the first examples where even the eyes and the hands were used together as an input mechanism. Yeah, so yeah, but let's get back to now, to 24. And yeah, now I'm a bit more active in social media, and there was an interesting debate of whether systems, whether developers and we should focus on hand tracking more, because that might be the future. And then people were like, oh no, we need controllers, right? We need the precision. We need them for games and everything. And they have been so amazing with all the previous VR devices. So there's this whole debate happening between, do we want hand tracking? Do we want controllers? And obviously it's not a yes and no thing, right? Ideally, you have a system that can support all these variations. But the big question is still, what should be the default way of interaction? What do you want to tell your consumer who just bought the device? What's the standard way to interact? But I think this debate is actually missing a significant point, and that is that the Apple Vision Pro is not supporting controllers at the moment, but it's also not only hand tracking, right? It's actually hand tracking and eye tracking together, and I'm very much I'm sure that it's a new thing and cannot be easily compared to hand tracking itself. So this discussion is not just hands versus controllers, but it's actually eye and hand versus hands versus controllers, if you will. Yeah, and so there's been a lot of comments on the Apple Vision Pro. I've collected them. I'm happy to hear more about it, since I've done a lot of research on it, and yeah, a lot of positive comments, but also some more critical opinions about it. And yeah, so the amazing thing is that it feels like something something familiar, because we do the gestures, and also something that is totally unnatural, right? Because we cannot interact over distance with the hands. But yeah, that's what I think that contributes to the idea that it feels more telepathic, or has something some like connection to your mind. Yeah, but in practice, of course, it doesn't work with everyone perfectly. What you can see here on the stats on the right. So for some it works, and then for some it doesn't work that reliable, like under 90%. So under 90% of reliability is quite bad typically, right? You don't want any input device normally, like a touchscreen or a mouse that works at 90% or something. Like typically it's almost 100%, and that's where you want to get. But this is also something to do with eye tracking hardware and sensing exactly where you're looking. And these things, I think, will, from a hardware perspective, this is going to improve, in my opinion. But the human perspective of how can I make this work, and how fundamentally different is it to only using the hands? That's kind of an open question. I think there will be a lot more happening now that Apple has brought it out, that a lot more advances, a lot more improvements, and new research, new explorations into using eye tracking with the hands together. But yeah, so it's quite a hot topic. What it's also not fully clear what does it exactly mean using the eyes and hands together. And yeah, so in principle, my motivation has always been that, you know, whatever device you use, in a typical interaction, you know, your eyes are somehow part of it. So since the beginning of the computer, you know, the display has been optimized so that you can see things nicely, you can perceive it, and you can control with your hands. But not much has been really exploited for the eyes as an input, you know, on a similar level as the hands. Although there's the opportunity, right? Because the eyes are almost always involved. And yeah, you can also see that eye tracking itself has been developing quite heavily. Initially was used by psychology, heavy devices mounted on the user's head and allowed to understand kind of eye movements, how our eyes move and work. And this then developed further into integration to different devices. And nowadays we have it in headsets. And I think in any potential headset form factor, it could work because it's the sensor itself is not a huge cost. Yeah. And lastly, in the end, the interface design is about understanding the difference between the hands and the eyes. And somehow this is obvious, right? Because with the eyes, we can look, we can move anywhere we want. And with the hands, we can do things. But it's to actually implement it as a potentially universal input paradigm, you need to consider a lot of different aspects to it, because the eyes can wander around like crazy and the hands can still do. You know, I could just, is this a gesture now or am I just talking? It's a bit hard to distinguish that. And putting both of them together could lead to a lot of error, but also a lot of interesting new synergetic properties. Yeah, okay, I'm going a bit too deep here. But from a scientific background, what motivated my work was actually that there's been all these works, but they, you know, like it wasn't really clear what to use for the hands and the eyes. So people were using eyes and hands for pointing. People were using the eyes to move objects around, right? To manipulate objects. And there was no clear paradigm across all of these examples, like which one would really work well in the context of a device platform. And so and what I kind of also noticed that most of the work was focusing on indirect input, like a mouse or a touch screen, or, you know, you have a large display far away and you want to interact with it. And I think what kind of fell into the background is the direct input, things we're doing most of the time, like multi-touch and now also in VR hand tracking. These more direct ways of interaction make it very easy to use. And I think there it's really interesting to consider how the eyes can advance the hand actions. Okay, so given all of this, there was kind of my beginning to start thinking of a vision of eye-hand symbiosis, something where it's a human-computer interaction where the eye and hand information are getting together into a symbiotic way. And if you think about it, there's just too many ways, right? The hands can do different gestures, they're highly flexible. You can have two hands, you can tap, you can use it on the screen and not. And for the eyes, there's a lot of different characteristics where it's just unclear, does it actually work as an input method? I mean, they're related to attention, to cognitive processes, but benefits at the same time are, you know, it's there's no effort of moving your eyes, right? It's very easy to just look at me or look at the slides or look at a specific word. And it's instant. So there's like very different characteristics that can come together. So why is it actually so special to use the eyes and hands now? How is it a novelty? And And I think an interesting framing for this is to think of time and space in a way. So obviously in space, if you consider direct input and indirect input devices allow you to interact over distance. So you can interact with things that are far away. Direct manipulation is typically focused on near space, right? So you can interact with something that is right in front of you. And this is also represented in the input. The moment you move your finger towards the screen, you just interact, right? The moment you move your hand to an object, you can interact with it, just tap on it and so on. But with indirect input devices, you always have an additional step of moving the cursor. So if I think of, I want to do that, I can't just directly point at it. I would first move the cursor there and then do something with the object. So that's the time dimension there. And I think it's the combining the eyes and hands is some kind of middle ground. So it's almost like a new class of hybrid interactions. And this relates to the eye and hand methods use the same kind of gestures as direct input. So you can instantly interact at touch down or at a hand gesture, but still interact with anything you see, whether it's far away or close. So that's kind of an interesting aspect to it. Okay, it was quick, but yeah, let's. Now that I've motivated kind of from the scientific background and told you about some the overall framing, we can go more concretely about the interaction possibilities with gaze and pinch. And in the end, I think there's one way to really summarize the difference between direct manipulation and eye and hands. So with direct manipulation, you can always interact with exactly one target from one position of the hand, and it's like a one-to-one mapping. Like you move your hand there, and that's it. And this is completely opened up for the eyes and hands. So I know this sketch is a bit weird. Some of my students told me that it doesn't make sense that there are three hands. But the point is just that with the eyes and hand interface, you can, in a sense, interact with any target you can see from any hand position. So this, releases you kind of from the physical constraint of having to be there. But it also releases you from, having a specific point from where you interact, so you can put your hand anywhere. And that's kind of the more of a different perspective on interaction. Interaction design. So thinking of multi-touch and hand gestures, I have to say that it's the concepts that I've kind of investigated for multi-touch will work very similarly for hand tracking gestures. So the gaze and touch approach, what you can see here at the top, is it's almost the same with hand gestures. That instead of a touch gesture, you would use a hand gesture, like a pinch gesture, in effect. And the main concept here is that there's a clear division of labor between the eyes are only selecting, nothing else. So nothing would be triggered in any way when you're just looking around. You would get some highlighting, you can interact with something, but that's it. And the other direction is that the hands would only do the manipulation and nothing else. So, and this kind of means in the selection part, the hands should not be involved, and in the manipulation part, the eyes should not be involved. And this is quite a key important difference to previous work, because there was always like mixed up with different types of concepts. And let's just keep it simple and just use this kind of paradigm. But it should be even stricter than that. The eyes shouldn't. So when you do the gesture, the eyes shouldn't be still involved in the action. Meaning that what you can see here on the right side, that If you think of a typical input system, you get a down event, like a touchdown or a pinch in. Then you have the movement of your hand on the screen, like a touch drag gesture, and then you have the touch up gesture at the end. And only the moment at the touchdown, the eyes are used to select, and then the hands will take over. So yeah, I think the last fundamental aspect of what you see on the bottom left. So that's where it gets a bit more challenging with gaze and pinch or gaze and touch interaction. When you want to select multiple objects, so with if you have like two objects, you can easily just move your hand and select them at the same time. And with a touch screen, it's easier, right? You can just touch them with two hands or just two fingers. But the eyes are always one point. So if you want to select two different targets, you need to do this sequentially. And this kind of introduces a different behavior for the eye and hand interaction, which makes it potentially slower to select multiple targets. But at the same time, you also have the benefit that you can reach anything, right? So you can look at faraway objects. I can touch down with multiple fingers and select multiple, and then make one dragging gesture or something. Okay. From now on, there will be a lot more videos, just more exciting. So I told you a few of the theoretical design principles, but here there's I show you a few examples on the tablet, and starting with the top left. Here, just depending on where you look, different parts can be scrolled. I guess something similar can be done nowadays as well with the Apple Vision Pro. So this is kind of a very basic change of the normal default interactions. And it's very easy to do, right? Because the whole window moves, and it's not really triggering anything specific. So if you accidentally scroll an interface, that's fine. Okay, and then you have things like on the right, image interaction. So any object can be selected, of course, and you could, in the same interface, you can just let the user tap, and that would lead to selecting the current image. And you can easily also extend that to two-handed interaction for zooming. And yeah, and there's other options as well, like what you see on the top, on the bottom left, the swipe and quick menu. So what we did here is just thinking, okay, we have this kind of typical interface. I think at the time I was looking at an image gallery on my phone, and they had this like quick menu at the bottom. And so when you open an image, you had two options to go to the next. You either do this, you just select, you tap on the object on the big image, and then you would go to the next one, or you can take the quick menu at the bottom. And yeah, instead of just having to move your other hand in there, you could just either you look at the main picture, and then the drag and gesture will activate that, or you can just look anywhere on the quick menu to do that. Yeah, and the last thing that I think is quite interesting if you want to make that even more complex, drag and drop. So here I'm selecting an image with a finger, and then I can use the same hand to navigate by just looking at the menu, and then I can finish my dragging task. So there's these more advanced actions where you can kind of select something directly and then navigate with indirect gaze-based inputs, and then come back to using the direct dragging. That's kind of, it feels like super complex in some way to explain that, but if you see it here, it's just a very basic that I look where I want to navigate, I select that, and then I just finish the dragging task. So it's possible from a user perspective to conceptualize different direct actions and indirect actions together. And I will also go in more depth after this. Yeah, and an important part when extending to 3D is similarly to use the whole gesture set in a way. So gaze and pinch, most people think, okay, it's a way to select something. I look at that button and then I can do a pinch gesture and then it's kind of over. But what you get for free is the whole gesture operation. So any gesture you do with your hands can be mapped then to whether it's interaction with one target, two targets, whether you use bimanual interaction, whether you use two hands on one object or two hands on two different objects. You can easily interleave that. And as a user, it's also very easy to just switch between different mappings. So here I have taken one object, pulling it up. Then I'll get in my other hand to resize my TV. And then I release it. I use just one hand here. And this is a different case where I looked at the TV, I moved it up, then I looked down at the little table, and then I can move that with the other hand away. So this is not something that I explicitly wanted to show or something. I just played around with it. I built the whole mapping with gestures, and then it was, it just came intuitively that you can do the same gestures that you did before, and it's easy to kind of transition between interacting with one or two targets. So this is also another important aspect, because if you can support gaze and pinch, just why not support the whole gesture set immediately? So this, I've got to excuse my application design. So at the time I was just thinking I'll load up the first environment I find in the asset store. And there was this desert-like environment. And I didn't put much effort into menu design, so they look a bit weird, like having holes in here and everything. But it's just to make a point. And the point here is, how can you be more precise than the eye tracker? I'm definitely a fan of making targets big enough so that you don't need to think about that. It just always works as you expect, and you just use the eyes to select, and the hands will just do a pinch gesture. But for some cases, it's not like that, right? That some applications might have a lot of small buttons, you might have a big menu or something. So the question is, how can you advance that slightly more? And when I tried out a lot of different of these options, in the end, I always, came to the conclusion to use these two ways. So on the left one, it's for slightly bigger objects, and it's for something where you can immediately make a more precise selection. So I walk you through it. The circle is showing where the user's looking at this moment, and you can see that I'm looking around, and the moment I pinch, the button is highlighted in green, so what I would select. But if it was the wrong target, I can still refine it with my hand. So I move around, as you see, and only the moment I move up, the actual selection is confirmed. And then, you can continue with the application. So this works in some way that it's a one-off action. So you refine and then you release, and that's it, kind of. But in mouse-based interfaces where you have true high precision, it's you might want to do even more steps to be more precise. So you might move the mouse multiple times to select something. So this is kind of a different type of interaction model here, where the eyes would only select the whole menu, and that's a bit cleaner. And then the eyes don't do anything anymore. So it doesn't matter where you're looking within the menu, but there's also a persistent cursor on the 2D window, and you can move it around with gaze, with pinching. As you can see, as a pinch drag will move the cursor, and tapping will activate something then. So yes, I would think like this on the right is really nice if you have just so many things and you have to select from there and then just use a mouse cursor to do that. And on the left is something more for a quick action, but you still want to be able to refine a potential selection. Yeah, it's interesting to think of other ways. So in specific use cases like zooming, it can be even interesting to use the eyes during the gesture. So what we did is we performed a user study where we kind of compared direct pinch to zoom on a touchscreen, what you can see on the left, and on the right we had an alternative variant where when you do a pinch to zoom, you will actually zoom into the position where you're looking, and that continuously. So as you can see here. And what we found is actually quite beneficial, because in the direct version, the moment you pinch, so even if you're really close to the target, because you're magnifying the whole view, you get less and less accurate. So you can see that the fingers are kind of moving away from the intended center here. And on the right side, you see this gray circular cursor here, which indicates just where the user is looking. And while zooming, the user can, kind of keep looking at what they're mainly interested in, right? The center of zooming. So in this case, the zooming operation was keeping more accurate, and that during the gesture, really. So I think especially for zooming use cases, one needs to consider, should we have continuous eye-based zooming? Will the user in my application be looking around when I'm zooming and then don't do that? But if it's really a goal-oriented zooming where you want the user to be as fast as possible, this might be actually quite an interesting alternative to use. And I know the Apple Vision Pro has some kind of zooming with 2 hands and so on, but I think this idea that the gaze-based zooming keeps you kind of focused on what you're interested in. It's not only a nice way to zoom over distance, but it actually can improve your accuracy. And if you can zoom in more accurately, you will also have less panning action. So this can lead to reduce the complexity of gesturing around. Okay. Yeah, so that's the time here. I actually don't see anything else happening because I just have the full screen. So if something's up, just let me know via voice. Okay, so the last part is a bit more experimental. Almost last part. Yeah, we'll skip this part because it's about user studies. So if anyone wants to know empirical information about eye and hand interaction, let me know. Okay, maybe I'll quickly go over it. So here we compared just a direct touch, what you see on the left, and a gaze-based approach, what you see on the right. And we have our standard way of evaluation in our research field. In the end, our results were that the direct touch variation was still faster than the gaze-based approach. But for users, this didn't really matter because they were happy because it was much less physical effort, as showed here. And most people preferred the eye-based approach because, in the end, it's just about you only need one hand and little thumb presses instead of 2 hands, and it's kind of a clear difference. We also compared gaze and pinch to hand tracking variations and also some in multimodal ways. But I guess the interesting part is hand ray. Hand ray is kind of what is often used as the default in systems like the MetaQuest uses the hand ray to to point with a hand and then just do a pinch gesture. The HoloLens 2 is also using that as the default, in addition to direct touch, of course. Yeah, but we compared it for distant interaction here, and here, and different to the multi-touch study here, we had a clear result that all the gaze and hand approaches led to a better performance than hand ray and another baseline we had. So yeah, our work kind of gives kind of clear empirical evidence to using eyes and hands for performance. But of course, it's not the whole picture here, because then there's some more fundamental differences there that I'll go into soon. Yeah. So the last section is on a direct and indirect interaction, which I think is currently a bit more experimental. I mean, what we have with the Apple Vision Pros, you can use gaze and pinch to interact, to use indirect gestures. And you can also have content directly in front of you, right? And then you can use the direct touch and pinching gestures for that. And I've been quite interested in mixing this up a lot. So one of my earliest demos in this was with a stylus, where you can see here I'm just doing a typical design and drawing task, and it switches automatically between using the stylus indirectly and indirectly in this example. So what's actually happening is that the whole interface, wherever you're looking, you would always draw normally with a stylus. Just strokes. You can write, you can draw something. Only if you look at the menus, the input of the stylus changes to indirect input. And then you can do something like that, where you draw something directly and then you look up, and then you can change the color cursor by a drag down gesture with a stylus and continue on that. It's relatively easy to just look at the menu and do a quick gesture with a pen. And yeah, and this is also, it's not only about the ability to switch between direct and indirect input, but also that how do you design the menus then that they, because now it's indirect input and the gaze is kind of just highlighting the target. Should the gaze be used to immediately select a button also, or should it be used in a more implicit way? And I wanted to put a lot of small targets in there, so it was impossible to just use the eye tracking to select here. So in this part, I made it that it's like a slider now, so that you can change the current cursor the moment you look down, or just like that. It could be even one button, and then providing a continuous value to change the line width. So it's interesting to think of how do menus actually change, and what kind of input models can they support now with indirect input. And then if you have scenarios like this where you want to, like Photoshop, and you have a lot of menus, how can you quickly change all of these options? Because of course it's not really about speed when you're designing. You want to be creative, and you might have a lot of different goals when you're designing. But imagining that you would work on this for hours, maybe for days, maybe it's your main job, right, for years. And if you have to move the stylus to the menu every time, there could be hundreds of times where you move up and down. And I think a universal mechanism that allows you to switch between direct and indirect input just by looking up, I think that could help a lot in reducing your physical effort and make them more comfortable. And this extends easily to more complicated tasks. So here there are, in a sense, 3 different inputs integrated into one. And this is getting a bit harder to understand, I guess, but I try to give my best. Let's start with the normal input. So the stylus, when it's directly on the screen, it would just create new points for a new vertex that is connected. And when you then, so this is the circle shows where I'm looking, right? And I want to interact with the finger. So normally my eyes are in the center of the screen, as you can see here. But when I move the stylus out, a mouse cursor is instanced here where I'm looking. And the mouse cursor is then moved with hover movement of the stylus. And then I can tap down when I select something, and I can make very fine adjustments, as you can see here, to edit the drawn strokes I just had. So this means, in a sense, that the switching to indirect doesn't mean it's just about menus somewhere, but it could also be something online to change to an entirely different interaction model, like from touchscreen, from direct pen input to now it's mouse control. And by just visualizing the mouse here, it was much easier to understand what it's actually about. Yeah, and the third thing, as you've probably noticed, is that my other hand is just doing pinch to zoom gestures, and there, from a design perspective, it was kind of obvious to use the eyes, because then the hands don't get in the way in the middle of the screen. So, and I could just do it, in parallel and at any time I wanted to. So yeah, there's a lot of ways you can combine direct and indirect inputs. And here's another one that uses, here the hand can kind of scroll the interface, but you can also instance a cursor here, so it's a similar concept. So you can make very precise actions. And I think this kind of thing is quite important in browsers, because a lot of browser interfaces they're not that optimized for mobile input. So having the ability to instance a cursor, but also the ability to do the normal flicking and gesturing, that's ideally you can somehow put that into one interface, then the user can easily shift between these modes. Oh yeah, and finally a VR example, and this might be one of the last. See, the time is getting it's getting quite late now. Okay, so this is in a sense two examples for direct and indirect input in VR. This has been done by Benedict. He was a bachelor student who at the time did the project with me. And so here you see a hand menu, and I can directly take a furniture object, and then I just look at the place where I want it to be, and then I release to finish it. So it's like one unified action, right? I take the object, and then it's immediately transferred, and in one gesture, I finished the whole thing in a way, just one pinch gesture. And similarly on the other side, what you see here with the Lego example, but it's slightly different. It extends the menu example I showed before with the stylus. Here, you see the nice sleep motion default models for hand tracking here. Here what happens is there's a menu at the top, and if I want a new piece, I would look up, pinch. So let me do this a bit slower. So I look up here at this object, and then when I pinch, it's instantly moving to my hand, and then I can place it. So the menu is, of course, deliberately placed at the top so that it doesn't go in the way and doesn't trigger any accidental eye actions. But it's very so seamless to get objects close to you and then continue working directly in a way. I've showed this already. I'm gonna skip this part to finish up. So I wanna finish with citing an article I read recently. So from Scared Ghost, I don't know the actual name, sorry. So he posted about what does not convince me of the eye and hand interface of the Apple Vision Pro. So really problems that could be happening. And there's, of course, the tracking problems. I think that's something that will improve. And it's also kind of based on how you calibrate and how well the eye tracking works specifically for your eyes. And there could be a lot of variability. But yeah, normally if you set it up right, it should work. But I think this is a tracking issue, and yes, it's an important one. The second one, input, the eyes shouldn't be used at input. I think this is a bit hard. It's true. It forces you slightly more to look somewhere and go a bit away from your natural eye movements. And what is natural anyway? There's always this thought, right, that is it my argument? I don't know, but you look at the eyes at the button before you do it, so why not use the eye tracking? But it's not that simple, right? Sometimes you don't do that. The prime example is, of course, text entry. But even in other cases, it might not be like that. And I think to really get a grip of this problem, you need to understand at which points, which kind of tasks are, if you have 100% of tasks in virtual reality, and some pointing tasks are those where you definitely look at them, some tasks are there where you definitely don't look at them, so you're kind of forced to look there before you do it. And then there's a bunch of tasks in the middle where it's not fully clear. And it's important to understand across all these operations you can do in the operating system, where how often will the eyes be there, right? And is that enough to replace the default UI of just hands interaction with something that is really based on the eyes? So will the benefit that I get from it really be sufficient so that any potential issues I might have with my traditional hand control is really not a good alternative there. Of course, then the last thing is fatigue. That's always quite a critical thing for me, for eye fatigue. I never experienced this in my systems, and I've been like the crazy power user for 10 years now. And I think it's eye fatigue from a scientific background has often been reported, but also because often the eyes have been used with dwell time. So you only use the eyes to interact and manipulate things, and then you need to put more effort in using the eyes. But the whole idea of gaze and pinch, and also the gaze and touch variation, is that it uses the eyes minimally, like at almost zero, only at the moment of when you start a gesture. So otherwise you can look around freely. So it's designed to avoid eye fatigue in a way, but it also makes sense that you can't fully get away from it. It's the same as phones, right? We can, we love the touch screen interface, but there's also fatigue happening at some point, because you might have the phone in some weird hand grip, and you might want to touch something far away and not use the other hand, and then let's say, and you might be doom scrolling for hours, and then it's possible to get fatigue, of course, but I don't think it's a critical issue that stands in the way to bring this interface even more forward. And of course, otherwise Apple wouldn't do it, I guess. Yeah, so my last point here is that I've made an article on gaze and pinch design principles. If you want to get more in-depth information, or at least my view on it based on the scientific background. And I think division of labor, I mentioned it a few times, that's the key overarching concept. Minimalistic timing, so don't use the eyes everywhere. And then infallible eyes is also another aspect, that we can't look wrong, right? If we want to look at something, we do it. And with the hands, it's possible that we overshoot, right? We could be fast and we could be overshooting because we're too fast. We could be slow and then we are very precise. But with the eyes, there's nothing like that, right? The speed is almost constant. instantly hit the target, and you can't be wrong, right? There's no like I cannot overshoot or something, right? It's impossible. If I want to select a button and I wouldn't look at the button next to it, right? But of course, this makes it a lot more critical that the eye tracking works. If the eye tracking is somehow not showing you the right point, then it's very weird for the eyes, because it shows another button highlighting, but you're looking at another button, and then you look over to the highlighted button, which is the wrong button, but that changes it again, and that leads to even more errors, kind of. So the UI has to be really fully supportive of the infallible eye, so there's no error possibility. Yeah, and other things and problems I also mentioned that are kind of in there. Yeah. All right. Yeah. Overall, I think it's the last point here is that, you know, we think of an action. We want to click that button. We want to open that song. We want to start that movie or something. And then after we think about, we act on it. And I think integrating the eyes in this action process has the potential to really change this dynamic, that you have a thought, but you might finish the action much faster and get back to your next thought. So if you can, you know, think, if you're more efficient in your thoughts and going forward with that over time, that might lead to a different way of thinking and how we do actions. Okay, anyway, this is the end. So thanks for your attention. I hope you got a little bit more on what I think of the eye-hand symbiosis. I think it's a revolution, not only for XR. Yeah, and so the Apple Vision Pro may just be the beginning and lead to a lot more integration of these multimodal systems. Yeah, and our current research team here is exploring a lot of new directions in this space.
Cool. Thanks so much, Ken. That's fantastic. Yeah, got a lot of wows in the chat at various points. People were super excited. Yeah, that's fantastic. I've noted down a couple of questions, but I'll kick off with one of my own. So I guess a lot of the examples you showed were quite gestural. So you're relying heavily on, in terms of the hands, on using gestures that are sometimes not necessarily 100% links to the action you're doing. And without eye tracking, using gestures quite a lot can lead to a lot of accidental activations or more cognitive load. Do you feel like eye tracking helps reduce this or adds to it? So does eye tracking add more cognitive load and more accidental activations, or is it something that helps out there?
I guess it's again this thing of different use cases, of course, that hand tracking, you know, it represents real life gesture actions, so it's you know, it's never going to go away or be replaced, in my opinion. It always it's important, and that's the most natural way of interaction. And but when you actually try it out, there's hand tracking, and when you want to select something just with the hands, you know, you either have to move closely and touch a virtual object, you don't have haptics, or you point with your hands and so on. And I think you need to support these basic actions, but there's actually quite a lot you need to support, from rotation and tracking the whole hand and so on. So there can be a lot more potential for errors because you need to support more gesturing. While the gaze and pinch is just, you know, in principle, it only works with just pinching, right? That's in theory an easier problem from a computer vision perspective, I believe. I don't have a clue about that, but I guess that's every time, you know, I work with students on a project, the first thing is, so let's just do a pinch gesture, because that's always the easiest and the most reliable to use. So it's from that perspective, I think it can make it in some way more reliable. But yeah, then you add all the potential issues from eye tracking, and it can also be a double unreliable effect in a way. Yeah. it can go both ways, but I felt like it's simpler to interact with the eyes and hands than all this gesturing. And when I use the menus, the Quest or the HoloLens, I felt like there's always a bit more effort involved. But I mean, effort can also be good, of course. Activity, while gaze and pinch makes it like you don't need to move your hands at all anymore. You just that's it.
Okay, cool. So earlier on, Nikki asked, does the process feel more engaging to you when using gaze and indirect touch? She said she felt much more immersed in the process that way versus just using like styluses and gestures. So I guess this was talking about the more 2D applications where you're using gaze there.
So whether it felt kind of more intuitive than 3D or...
I guess whether it felt more engaging rather than just doing direct touch. When you add gaze in, did you find the experience became more engaging?
I found this is still the lowest effort I had in any interface, because even pinching is still a bit of effort of kind of two fingers and holding your hand in a posture, while when you just tap, like it's like really, I don't know, less than a centimeter movement, right? And it felt like there's no effort really when you just look around and tap. So I don't know if that kind of helps for the question, but it just that was kind of my how I feel about this kind of thing. And I could imagine just having a touchscreen in your hand, and you could also in VR look around and just tap. But it would be interesting to compare even 2D to 3D.
Cool. Melissa said, does making the reticle visible to the user change their behavior? She noticed that the reticles visible on a lot of your examples, and assumed that maybe that was just for example's sake, but was interested in knowing how that affects user behavior when they can see the actual output of their gaze.
There's a huge effect. So I normally I tell everyone, don't use any cursor or reticle or something, because it will just be distracting, and it's mainly for debugging, I guess, and for videos, like when I show it in presentations. But I think I mentioned it also, that when you see a cursor and it's not accurate, then you try to look at the cursor and then it just moves away even more, because the eye tracking then thinks, it's getting offset again. So this this cursor is very distracting, and I definitely recommend just highlighting the object in a way, but I don't have to recommend that, because Apple has a lot of nice guidelines on that.
Around that, what are your thoughts on the way that Apple has implemented gaze and hand tracking? They've obviously used similar techniques to what you've researched. I noticed the sort of zooming stuff that you were showing there is similar to how they showed off how to zoom in their photo apps. You said earlier you tried it out, so I think we'd all be interested in knowing what you felt there and what your hot take was.
So I think it's still, if you think of the core principles, like the division of labor and how to use the eyes and the input and minimally, and I think that's the basic concept, the basic guidelines, the principles are the same almost. But of course, it's not just the interface software that defines it, or the technique. It's like the whole operating system, all the buttons, all the menus have been like especially designed for that. And it's a fusion of the hardware and the software working together. Really, I think that's what they really mastered in their system. And of course, like I was just one poor PhD student building having a really shitty prototype and trying to put it somehow together. And it was, the hand tracking was just working here, and the eye tracking was just working when I'm relatively still. So it's a huge difference, I guess.
Cool. I mean, it's crazy that you've been doing this since was it 2016 that your first
So
papers were published?
So the gaze and pinch work was 17, and the touch screen work was kind of 14 starting.
Oh, wow. That's wild. So Suma said, I was wondering how gaze and touch can be used to have relative disruption or adding friction, as opposed to adding, like, helping people get quicker actions. Is that something you've looked into at all?
Reduce friction of the default touchscreen stuff, for example.
I think almost add friction in, and whether I'm not sure whether they were asking whether it's something in a positive manner or a negative manner, because sometimes you do want to add friction between an action that a user is doing, and sometimes you don't.
I remember some work that used eye tracking so that if you look kind of close to where you're touching, it would enable the touching. So that if you have your hand somewhere on the border and you accidentally touch something, that this would be ignored. So there's the possibility to use eye tracking to kind of reduce this kind of friction. But at the same time, if anyone would use the system I built for gaze and touch, there would just be errors all the time, because I was just so used to this principle. It's the same with the Apple Vision Pro. I guess at the beginning, at least I read it, that a lot of people are still moving their hand towards the targets, but it's not necessary really. And that might lead to potential frictions, right? It makes it a bit slower because you can just start without moving. And that's something you get used to. And that's just a basic principle, right? Because then you can continue with, how would it work with zooming and different types of interfaces and so on. And then you get slowly used to it, nowadays, at the beginning, the touchscreen was very simple, right? But nowadays, the operating system, Android or iPhone, when I use my wife's iPhone, I don't know how to use it really. So I guess these kind of things will prevail in any way. But the basic principle, I think, it's, you can kind of get used to it, but it takes a bit of time because, the eyes are not there in the real world, right? You never control something with your eyes in the real world. I mean, except for when we look into each other's eyes, and then there could be something subtle happening. But otherwise, it's no. I can take this object with my hands and move it around. Right? I manipulate the world, but the eyes, there's nothing like that. So it's like a huge surprise when you first use this, and you've got to get used to it some way. How you synchronize your hand actions with the eyes.
It's interesting. I guess I think I had a debate on you on Twitter a while ago about a similar thing. And so, how do you marry that that distinction between when you want to look at something to interact and when you don't want to look at something but you still want to interact? So, for instance, I'm looking over here and reading questions that I've noted down, but I'm using my mouse in my peripheral vision to mute and unmute myself when talking to you, and I'm not necessarily looking at the button as I do that. How do you see that sort of problem, or do you just think that's a design problem that you have to kind of ignore and say, okay, you're using gaze in this context and it's up to the designer to work that out?
Yeah, that's it's a hard one. It's like when you on Twitter, when you mention, but for text entry, how would you do that? Now, of course, it doesn't work that well. but on this particular one, you're looking at the comments, and then I mean, first of all, I think the mouse should never be gaze enabled. The mouse should just keep the mouse, because there's no effort with the mouse, right? You just move a little bit, you're everywhere anyway. So you don't gain that much from the eye tracking part, in my opinion. It's more like for direct inputs like gestures, where it's really useful. And there, it's the questions were, would you do gestures somewhere in the air, and you want to select exactly what's in the air, but you're looking somewhere there? I think it's very unlikely. And that goes also back against thinking of all the possible tasks you do. How many of them would that happen, right? That you look really far away and you do something here, and then it's a compromise, right? And it will be buggy in these cases, but you can win something in the cases when you interact over distance or something. And Yeah.
I guess it's just like as you said, a compromise between the designer and the application you're doing, and it's up to the context that you're using it in, right? Like Suma was saying here, playing important music, or maybe you're like in an immersive application and you're a DJ and you're scratching your decks, and you don't necessarily want to look down at that because you know the feel. But whereas other kind of more day-to-day, everyday activities, it may be that you're just looking to pinch and click, and that makes more sense.
I have to just follow up on this. Of course, you can also see it as an opportunity. So gaze and pinch right now is just using the point where you're looking. But what you mentioned with this mixing direct and indirect input, you could have something like, I look there, I'm controlling something, you don't see me there, I'm controlling something, and then when I look at my hand, it could warp here, right? And then I could continue. So it could take advantage of what I might have here, actually. There could also be that I look at the delete button, and then I press my finger here, and then this object would be deleted or something, just to quickly switch modes. So it could be actually at some point that we might be so used to it that we can interact with both points, the hand point and the eye thing, somehow in parallel.
Cool. So getting back to some of the questions we had, Cam, you asked a question about radio button examples with indirect gestures. Well, I didn't really understand what the question meant. If you were able to rephrase that, I can ask that again. There was one around whether you've done any research using the headset direction instead of actual gaze, since eye tracking technology is expensive. To hop in on that before you do, I recently, as in on Tuesday, was user testing an application that used headset gaze to activate UI. We had UI to the left, UI to the middle, UI to the right. 100% of our users just did it without thinking, which is really interesting. But I wonder if you've done any more formal testing than the user test I ran internally on Tuesday.
I know a few works on this, and actually a lot of my inspiration for the VR work came from the HoloLens 1. And the HoloLens 1 had this head pointing, and you do this air tap thingy. So it was already very close to, I think, what we see now. But I think moving the head is, it's not that good. I don't want to move my head much. I mean, I move my head, but not like in a, if I have to move exactly to a button or to, okay, you mentioned like just like areas, maybe that's fine, But I didn't really see it as a concrete, really useful technique, because you can always think of, okay, why not use the eyes, and that we would be more accurate in a way than the head direction. But there might be other use cases, of course, where it is. I have a Hans Gellersen actually in Lancaster University. He worked a lot on combining eye movement and head movement together to make commands. So you don't have to do pinching or something. You can just look somewhere and do some kind of head gesture or head movement to do the clicking. That's also, I think, a very interesting alternative to have and potentially in the future.
I've definitely used the more general head direction in Pico headsets. You can use it as a cursor, and you hit a button on the side to select something in a menu, which is really useful because I hate picking up controllers and having to charge them. It's just fun there as well. I guess it's useful to think of it almost. I like the cursor that you can enable on eye tracking experiences because it shows you how precise or imprecise the eye tracking is. Mm-hmm. And the cursor for gaze is going to be like your entire field of view, right? So you've got all that imprecision and then uncertainty to play with there.
I think I even saw someone making an Apple Vision Pro copy interface just for the Quest 3, with head pointing.
Nice. Yeah. When I first used the Vision Pro, I was so used to my gaze being tracked by my head that my head was turning directly to each button, and then I was pinching.
I'm not a native English speaker, but is gaze head movement or eye or both? Or
I don't know.
okay.
I tend to use. I don't know. I guess gaze is more eye movement, but I've tended to use gaze as the head direction and then eyes or sight tracking. I don't know. It's probably just me using awful terminology.
I was just using gaze all the time, and now I don't want everyone to think I was just using head pointing all the time.
No, I'm sure they don't. Cool. So there was one question around accessibility and whether you see whether gaze and pinching can help from an accessibility standpoint.
Yeah, so I'm also involved with some associations on eye movement for accessibility, and there, it's like you have to consider the hands and the eyes as a continuum of potential capability, right? You can, I could just be a little injured, so I can't maybe move my ankle or something. I could, I could maybe be shopping, so my hands are busy with bags. There can be like different types of injuries you might have across the whole arm that could impact your performance in some way. So I think having this very minimal model of just quick taps and no other movement needed is quite nice, I think, as an alternative to direct touching with your hand where you have your full flexibility. So I think definitely it has a lot of potential in that direction. But then again, also, if we consider the whole range of different capabilities of users, then there might be a range of techniques. So it might not just be one way. You might also want to have an eyes-only approach, like a dwell time, to support even more the range of within the accessibility.
Okay, cool. So there was a few more questions we've had. So Cam said, between research discoveries and product implementation, they kind of usually pass in a couple of years. What research is happening now has the potential to arrive in products in a few years' time from an XR perspective in terms of eyes and pinches and hand tracking?
So someone asked me today, now that it's all out there, will you switch your research field? And I was thinking, no, this is just the beginning. It's gonna become huge, even much more than that. So that's the whole point of the eye-hand symbiosis vision, that gaze and pinch is one concept, gaze and touch is one, but I think there will be a first stage where we all just get used to it and to the novel eye movement thingy. And then after that, just, okay, now we know how to do that. Let's do even more than that. Like any potential combinations between the eyes and hands are, I think, of interest in the future. So and we're doing research in this direction now, but I cannot tell you anything about
it. Nice. Good team. So we'll keep an eye out. So John had a couple of questions. Well, his first was more of his observation, which is that he encounters a lot of moments in games where his eyes move on before he's completed an input. I was wondering how that impacts how you design for gaze tracking.
So when I was young, I was a Counter-Strike player. And there was a 3D FPS shooter, and you use your mouse for like everything. And at some point, you become so good that you just instantly move to a target and shoot. And but the whole concept is also different, right? Because the mouse, the crosshair, the cursor is in the center of the screen always. So you look at the center. You don't really look around much. So in principle, when I think of this high performance interaction, shooting games, it doesn't work with the eyes really, in my opinion. It also doesn't make sense, right? Because if you have like games like that, you want to use the metaphor of the game, like okay, now my controller is a gun, or now I can, punch to explode balloons or something. This is fun. This is cool. And I think for the eyes, there should be unique, specifically designed applications. So there's new ways for you, probably new genres, new types of applications, in my opinion. Right now, it's all just, okay, you have the UI, menus, you click buttons, but I think there's a lot more to it than that, especially taking advantage of the 3D space, how you can make something very physical, but still use the eyes for distant stuff to make it, then again, supernatural in some way beyond the physics. So there's, I think, some tension that is worth exploring. And I hope that, that there will be really unique apps coming out for the Apple Vision Pro, because so far it seems like it's just some demos, and the only thing that really works is the UI control with the eyes, while all the other iPad apps, whatever, they're not meant for the eyes, right? So it's yeah.
The other question John had asked was, he was curious if you've seen any studies where users are asked to perform gaze and touch-based tasks in an environment with distractions, where their attention might be split or drawn away.
So I didn't do any studies in this direction, but yeah, it's important. Obviously, when you get distracted, your eyes are distracted, and that could have a huge impact on the input performance. But not only that, like one of the first papers in VR with gaze interaction in 2002 or something, they looked at how well you remember the positions of the objects after the selections, and they found that if you use an eye-based approach, you're more inclined to forget where things were. While if you moved or you pointed with the hands, it's somehow in your muscle memory as well, right? So it helps you to keep a bit more information about what you've just done. But it's not like, but that's an extreme use case, of course. And even nowadays, when we move the mouse or doom scrolling, and so you just forget things anyway. But okay,
really
I don't know if that actually answered the question. Yeah, it's the distractions, right? But yeah, distractions are they could happen, but I think when we get used to it, and it's fine. And most of the computer actions we do, right, it's we just focus on task on screen. So I don't think the distractions will have a huge effect, but for most of the use cases, it's not like happening a lot that you get distracted. I mean, that's at least what I believe.
I love that. I want to read that paper now. That paper sounds great. I wonder if it's because your hands are more spatial controllers than your eyes are, so you're more used to in your brain mapping like your space out with your hands compared to your eyes. I think I saw someone compare your hands to lo-fi lo-fi cameras almost, where you're like, because you can feel things and feel space in a 3D manner. Yeah. So I think that was the last question we had. I did have one more that popped into my head, which was one of the first eye and hand tracking demos I tried was grabbing a ball and throwing it, and it kind of landing exactly where you looked at. And it was fantastic for like the first 4 times I threw the ball. And then I started to try and throw the ball in different directions, and it always hit the object. And I was like, the magic is broken. How do you stop the magic from breaking with eyes? Like, is there a point where it becomes too magic and too helpful and ruins the sort of natural, fun nature of the universe?
I think it can only go forward, like there's the VR 3D, but then, you could have similar concept for controllers, for touchscreens and so on. So it can only get bigger, the magic. But if we just think of magic in principle for something new, the novelty effect, right? after a few minutes, you don't think about the input, right? You think about the application, whatever you're having in front of you, rather than how you do things. So I guess at the beginning there's some magic, right? And then you will just get used to it. But if you have, if there's something where you expect the ball would be there, but it's there, I don't know. It's confusing. I don't see the point of this example, to be honest, because if you want to throw, it's a physical action, and you want to be able to throw with your own hand position, because that's the fun of it, in my opinion. And if you just make it eye-based, then there's, okay, you can do this task much faster, but still, what's the point of throwing then? Yeah.
That's fair. I think it's interesting. Throwing is a fun history. I think there's an interaction in Half-Life Alyx where if you throw something towards a bin, it tends to magically land inside that bin, no matter what direction you throw it in. So it's always like some magic happening behind the scenes. But yeah, thanks so much, Ken. This was fantastic. I think we're pretty much out of time. But yeah, this was such a great talk, fantastic discussion. Where can people follow you, find out more about you, see future updates about things you can't discuss yet?
Yeah, so I have to say thanks. It was also great to meet you and give this talk to an audience that I know typically it's just researchers, and I really want to connect more with with people in the industry. And Twitter, I typically update a lot of stuff, and LinkedIn. So if anyone's interested, they can contact me, or just follow me if you want. Yeah.
Okay, great. Thank you. I think that's it. Thanks everyone for hanging out. If you're not already, come join the XR Design Discord server and come nerd out more about XR design.